present a brief report on our today's speaker, B. Vasudev sir. Sir is currently working as a managing director in Fitech Embedded Private Limited and has 15 years of industry experience in embedded technologies, mainly on ARM and Linux. Sir has worked at major MNCs like LG, Wipro, MIC Electronics. Fitech serves as OEM for many electronic and embedded companies to develop and deploy their products at the lowest possible time with high reliability and quality using ARM-based SOM and SBC. The industry verticals Sir was engaged are industrial automation, mobility, and energy, medical or healthcare, retail market. Apart from his technical work, Sir is an active coach and guide for embedded developers and has actively spent his time to train the developers on embedded Linux, Yocto, IoT, Android system development. Sir is the mastermind behind DrugCode open source hardware platform. Sir has a mentor, helped many startups to build their products and position them in the market. We are very fortunate to have you as a resource person for our today's program, sir. Thank you, sir, and over to you, sir.
Yeah, so thank you for a very detailed introduction, actually. So let me quickly jump on the topic as we are already, I think, 7 minutes late. Sorry for that. Being a professional, so always we do the last moment presentation part. So it's always hard for us to gather the things. Okay, so now let me quickly tell my story of journey with wireless technologies. So from my career starting, so I started my career after my master's in 2005, basically. So with MIC Electronics. So we have been a telecommunication company and handheld manufacturing companies where I got an opportunity to work with multiple wireless technologies, right? So let me brief quickly about how these wireless technologies are like derived, and then as I told, like let me link my journey with that, basically. So first, if you really see the wireless technology, very basic wireless technology, which normally it is part of our life, it's very simple, is your IR, right? So that the very first basic communication which starts is your IR. So the best example would be your TV remote, right? Like, so it's really part of your life. So now it's a different story. Those remotes are also migrated from your IR to Bluetooth for your smart TVs. But I always start the wireless technology with IR. Now the second thing in which if you really see your the next wireless technology is your RF. So the best example I would give you is your car keychain, right? So the toys of your kids, basically, or the mainly kids, and then like the RF which has been used since decades in a very proprietary way, okay, where you have electronics devices for modulation, demodulations, modems, and then like you have your own other things to convert them into a valid data, basically. Right, so where you have a challenges. So what is the challenge? What is the challenge of IR when we jump from IR to RF? Is very simple. It should be line of sight. IR should be line of sight, and then short distance. Now coming to the RF, we can achieve depending on the tuning of the RF circuit and the power need to be transmitted. We can tune the distance. Now, distance is not a problem, and it became you need not to be really in a proximity or a straight connection with the receiver and transmitter. So now coming to the RF, we could able to solve the distance part, but coming to the data integrity part, so the conversion of analog signals to the digital and then maintaining the integrity is a kind of like, say, the protocols need to be developed. Nowadays also you have a software defined radios and other things basically. So you have a lot of work around it. Now slowly, those are okay when you have a car remote or toy where in which you have a very less data to transfer. Essentially, you transfer some commands to control them, right? So that's okay. Now, but when you really want to transmit huge data, again, the bottleneck here is about the overhead of the data format or the data packets, reliability of receiving the data was the major challenge. So then it's what the digital wireless communication protocols has started after RF, right? So now, the first, what I would say is basically the low range wireless technologies. Normally, we used to call it as a personal area network, PAN. Like your wide area network, WAN, basically. So, personal under these, not only the smaller range, but also the low power. So, the power plays a major role what the different technologies which we have been evolving. Today, as we know, the topic is on wearables. Now, the most sophisticated parameter in your wearable is your power, basically, right? So the low power, low range protocols has started evolving. The first kind of digital protocol which started with ZigBee. This was mainly from an industrial perspective. At least I do remember my first company, as I told, MIC Electronics, where in which we used to do these handheld devices, and mainly we used to cater on the utility billings and then energy meter or water meter kind of stuff, basically. So where the ZigBee has very early started as the major concept was wireless sensor networks, basically. So the WSN things has started, and under that, like one of the alliance is ZigBee Alliance, the standard, wherein which it has gained a lot of attraction, mainly in the industrial sector. And one of the major success story of ZigBee is its energy sector, actually. So it couldn't took up very much in other sectors. There are success stories, but like it couldn't take up as wide as other technologies, but still it is alive. ZigBee is still alive. Now, in this, the major advantage of the ZigBee was basically your mesh networking. So WSN is a concept of more about a mesh networking. So if you have a devices, multiple devices, and you have, as you know, these most of these personal area networks or low power things works under your ISM band of 2.4 gigahertz, right? So now in this, the maximum range, normal range, what you expect is 100 meters. Now, you know, if theoretically also, if I say 100 meters, now you say I have my Wi-Fi router in living room and I'm not getting it within kitchen itself, which is not even a 5 meters away. That's a different story. Okay, we can debate on the things in a different or maybe open session, basically. But it's all about the interferences and like when you normally tell a wireless range, you should always tell with respect to the environment. So normally in industry we say the range of this particular technology in urban, semi-urban or rural. normally from a business perspective, we never speak saying that like Zigbee can give 100 meters. So we always speak Zigbee it can give around say 30 meters in urban, maybe 60 meters in semi-urban, and in rural it can also even reach up to 100 meters. So that's how we always try to define, because when you are doing a research, that's okay, but when you are doing a business, the customer sits on you then basically, right? So the simple example as I have given, you install the router in your living room and you're not getting the proper signals and the data rate in your kitchen itself, right? So the coming to the Zigbee, as I told, it started with a digital packet format with multiple nodes connected as a mesh network, right? So this is the major takeaway. But like the Zigbee was an open alliance, but like the profiles and the next layers of the business layers used to be interoperable, but slowly each implementation of the stacks by each of the vendor, it gone in a different way, and interop has been a bigger challenge which has been faced when it coming to the commercialization. So as a standard, it is open, interoperability is there, but when it went into the market, it has faced a lot of interoperability challenges basically. So now the latest one is 6LoWPAN. Now on and above 6LoWPAN, there are multiple things. Your 6LoWPAN can work under 2.4 gigahertz, or you can work on a long range, which is basically sub gigahertz basically, right? So 1 minute, let me put on the pointer. So now these are good. Zigbee is very good for the sensor data and very low data rates. Basically, essentially, as I told, the major practical win situation of the Zigbee was industrial, mainly into energy sector. Japan is one of the biggest user, you can say, in terms of energy. Then what we needed is basically, this is more for a longer battery and extend the range with the mesh networking, but the data rate was very low. Now there are a couple of applications which wanted a higher data rate. They can compromise on the distance. So that's how the Bluetooth has been evolved. The Bluetooth was not nearly developed for the sensors. So this is mainly meant for the sensors, whereas the Bluetooth was mainly meant for the mid data range, wherein which you want to transfer, say like the commercial applications started mainly with your wireless speakers, wireless headphones. So those are the things which has started at a very early stage, right? So the Bluetooth mainly overcome that part. So where you have a mid data rate basically, and that's how like you have to compromise on the range. But now you have a different story. We will get into the deeper of this. We will talk a little bit more on the Bluetooth part. Wi-Fi basically. So the Wi-Fi is the biggest data rate in terms of your data transfer. Again, it works on 2.4 gigahertz. Now you have a 5 gigahertz. Now you have a latest technology, which is furthermore growing, the Wi-Fi technology. So at least in a wireless market, in terms of the business or consumer electronics, at least Bluetooth and Wi-Fi were the winners. And from an industrial perspective, there are other wireless technologies which might not be really known to the common man basically, but it is widely used in the industries. Okay, so now the next one is basically your 1 minute. Just wanted. Okay. Yeah. So the next one is your cellular technology, which started from 2G, 3G, 4G, now LTE, and now it is era of 5G basically. So the whole of the things will change. So Z-Wave is derived at a sub-gig level to extend the range. Now it's similar to Zigbee. Z-Wave is more popular in US market for the home automations and all. So as I told, the sub-gig is more on a radio level, but going further protocols, you have LoRa, you have Sigfox basically. So we will try to little bit debate on these technologies. So Thread is one more protocol similar to Zigbee for a mesh networking. Basically, it's again an open source. So these are the different protocols or the software protocol wireless technologies, what you can see when you go for a wireless development, right? So now these are a simple quick overview when to go with what, when you have a powered solution, so where you can plug in things and then you have higher data rates basically, so you can always go with Wi-Fi and other things. Basically cellular takes more power, but now in cellular you have a NB-IoT, which is again a promising part. So LoRa versus NB-IoT, that the different topic. So this is a kind of a small decision making chart you can take, like say when you want to go with what. So for a very quick conclusion, when to go what, at least some inputs from me is basically when you are doing IoT kind of stuff, so you can and industrial, it's all about what industry and what application you are talking. So you can always see these all are 18.15.4 basically 802.15.4 physical layers, and then on top of that IEEE you have different standards, right? So Zigbee, Thread, Z-Wave, so these are the one group of things basically. So when you are talking about some industrial automation, data, building automations and all, those are the kind of things basically. So LoRa versus NB-IoT would be one of the topic, if you can make out, and then maybe explore. We will try to connect anytime. I have a couple of lectures dedicated to LoRa and dedicated to cellular, mainly in terms of NB-IoT, which is an upcoming IoT standard, wireless standard would be. And then when you come for a consumer electronics, so now today's the topic is more about wearables. Now the first things when you say wearables, mostly you would be spinning around Bluetooth and Wi-Fi. Now in Bluetooth, what data rates, which version and all, we will try to see in proceeding slides. Okay, so as we were talking on the Bluetooth, I just captured the definition, but I think we are far away from this definition. So very simple, short range protocol, right? The beauty, as I told, the shift from RF to the digital technologies of wireless was more on the data integrity and data formatting, how you exchange, making the devices standard. Today, when you say Bluetooth mouse, so your Bluetooth mouse irrespectively should work with any computer. So now these are the standards, right? Like say in wired technology, USB has taken a lead. Similarly, in a wireless technology, at least today, you have Bluetooth at number 1 and Wi-Fi at number 2 for a devices. I mean to say devices, basically. Okay. So now coming to the Bluetooth versions, basically, so you have Bluetooth Classic and Bluetooth Low Energy. So there is a huge shift when the part of IoT started coming in the picture, basically. So now when you say IoT, you have very less data, and you might need the sensors which can run on a battery with a longer life. So that was the main motto of IoT sensors basically. So but earlier, as I told, the Bluetooth has started coming into the market to really cater a mid data range application. So the simplest example, as I told, your earphones to play your wireless audio. We have a wireless printers. So you might be knowing the wireless printers basically. So you have your wireless cameras. Sometimes you want to also see some pictures live. I still remember 2005 when I bought my first industrial module for 4,500, and then I was tweaking in our lab for a file transfer, audio file transfer and video file transfer, where like the data rate went up to 24 Mbps. So this is how the Bluetooth has started to cater on the mid and mid range, mid data range, below Wi-Fi, you can say, right? So now the BLE has been introduced mainly to go to the IoT space. So the if you see, we have written in reverse. So although the 2 Mbps, still you can have the application which you have been running on classic, that application still you can run on the BLE version with 2 Mbps. But essentially the evaluation or the challenges which wanted to be catered was basically the lowest data rate with the highest range, right? So you have now a Bluetooth long range files which can even easily can go up to 200 meters and 300 meters in theoretical, as I told again basically. So the long range files are specially made for 100 plus meters basically. So we on a theoretical basis, it is even goes to the 200 plus meters. So now to be more little bit more inside, if you really see that, like right, so that's what we discussed, the classic variant of Bluetooth, which was the initial technology in the Bluetooth. Then it has shifted for your IoT space, or what you call it as a Bluetooth Smart, and mainly catering to the IoT space. And for the less sensor, the less data. Today, when you say you have a tracking device, or you have a BLE beacon to track your to track a person within a premises basically, or you want to monitor some continuous data which need not to have a connection basically. So there are a lot of enhancement has been done. So on an architecture level, it also has changed. So the basic, the first started with a basic radio, and then it has been enhanced. Now there are multiple variants, as we have seen basically. The latest version which is currently running is 5.2. Let's see a little bit more on how it got more standard in terms of IoT basically, right? So this would be something more interesting, which we will try to see a little bit in detail. So now coming to the architecture, of classics. So this, you can see there is a Bluetooth radio followed by a baseband. You have a link management protocol, and then you have a link control access protocol. Once these links are done, so the data goes up. Now, once the data goes up, it is all about how you define your data, whether your data is a sensor data, audio data, video data, basically a standard keyboard for your HID kind of protocol. So those definitions, you can see these are the softwares which try to format the data as a particular usage application, and then it goes to your application profile. So similar to your USB in a wide, so you have some standard layers which do not deal with any data part, and then it is the formatting of the data which comes, and then like different applications on a user layer will use your, so a simple example, if you have connected your uh, mouse, it directly enumerated as a HID device, but before HID device, the USB to Bluetooth conversion within the controller, right? So which is taken care by some sort of your software packaging basically. So those all things comes as profiles. So you have a different profiles in Bluetooth. So earlier, as I told, so when we used to use the Bluetooth, so mainly OBEX and other protocols, we mainly used to transfer the files and all those things, because initially the Bluetooth was oriented as a mid data range and the data transfer for your file transfer from your mobile to PC, or some medical devices to PC and other things basically. Now coming to the Bluetooth, how can I just, so I was just trying to, okay, so I was just trying to make these, where it is, okay. Fine. So coming to the Bluetooth low energy, basically, so the little bit on the architecture level, it has been modified. So you can see the basic hardware layer called controller, where your physical layer and the link layer is there, and then the L2 cap remains the same. The logical link control application protocol remains the same, but there has been a significant change on this part, right? So the part is your, what we call it as a GAT and GAP. So wherein which you have these modules, the software layers, which takes care of your, so the GAP is more for your connection oriented, where now today you can make any wearable your Bluetooth device, but how secure it is basically. So how you can make sure that your Bluetooth device is sending the data to your mobile only. So the security is the major concern. So there has been a lot of modifications in the technology which has been happening, and the continuous enhancements in the stack level. So these are more from a software perspective basically. So where you have the GAP as a service which takes care of your connection, and now you have a connected less. Many times what happens, you say that like if I use BLE Bluetooth, I can talk with only one device. So now it is not depending on your application. So you can operate your Bluetooth in a connection mode or a non-connection mode. So those all things are managed by your GAP service. Then you have a GAT service basically. So under GAT service, so you have different, you can define different characteristics which are also called as attributes. So each attribute within your device can act as one of the sensor data. Let us take a very simple gadget, your smartwatch. So if I use a smartwatch as your healthcare device basically, so what all sensors you have? well, let us suppose the temperature sensor, your heart rate sensor, basically. So your today now there are non-invasive glucometers, and then it's all derived from different parameters, basically, right? So you have an accelerometer to track the body activity, the person activity. So now what you do is each of the sensor you can tie up with one of the attribute or so-called characteristics, basically. So under a one profile or a service. So profile, so there are different terminologies. One is your profile, which is nothing but what kind of device it is. So whether it is your speaker device, whether it is a audio device, whether it is a printer device, right? Like, so the profile. So now under profile you have a services, under services you have a characteristics. So each characteristics could be one of the attribute, which can be a physical data which you want to transfer. So below layer you are connecting some sensors. We will take one of the small example, whatever we are talking, we will take one of the small example of chip, and we will talk about all these things. Right. So essentially, on a very high level, to conclude on this slide, I would say you consider the gap as a connection manager, which will take care of all the device management part. GAT is your basically, so your data flow part, where you can connect to the different sensors and you can start defining your characteristics of the device and start transferring your data. So you will see all these things in practical in Mr. Gopal's session, which is in the afternoon. So whatever we are speaking in terms of theory, Mr. Gopal from my team, who heads the competency division, basically will go through our one of the device, one of the sensor node, where you can see how these things are implemented in terms of code, in terms of your hardware. So he will show you one of the complete example in terms of hardware and code. So my session would be more on a theory part, but I think since we have connected on morning, you have a little bit of energy to bear all the theoretical part. So now here we see the Bluetooth frequency band, wherein which essentially it is as I told, so initially 2.4 gigahertz is the ISM band which we start. So that's the ideal, because you don't need any license. So the band itself is made for free of cost for normal usage, right? So which has been divided for Bluetooth, it has been divided into 40 channels, and you can see within these 40 channels you have 3 channels for advertisement, basically. So we will see what exactly this advertisement is all about. So you can see the channel number 37, 38 and 39 basically are the advertising channels, and other channels basically is the blue one. You can see the data, okay, depending on the version and the variant. So this is all taken care at your physical layer. The data which is pushed to the link layer, and then like the data formatted. So these all things happens in your physical layer. Now, as I was talking, basically, so when you come over these, so using these components, right? Like, so using these software components, basically, so you start defining a profiles when you are developing a device. So for that, you need to really know the different Bluetooth profiles. So when I say really the Bluetooth profiles, So depending on what kind of device you are developing, basically, so you can take different profiles. Again, what I'm saying when I'm saying different profiles, so this is all about the software running on top of, consider we are electronics engineers, maybe like many of you guys are from software. If I'm considering myself as a electronics engineer, I would say I have very simple, whatever the RF technology, wireless technologies you take, you have a very basic modulation, demodulation hardware, which we normally call it as a modem, right? So which do all your stuff of converting your you would have converted your digital data and to analog, and you have given to this radio. So this radio transmits the data over air. Now, before that, when I say from my application, I am sending my key of a wireless keyboard, or like I am streaming an image from my mobile to my laptop or a TV, basically. So the data which is traveling, right, like it have a huge difference. Now how do I packet this data from my application to the middle layer, basically? So that middle layer is what these profiles we are talking about. So how do you format the data so that like every of the device who follow this profile uh, becomes a vendor agnostic, right? Like, so I can't say that like my laptop, Dell laptop, will work with only Dell Bluetooth keyboards, right? So you have to follow some standards. So those are the standards which has been made as a standard profiles, right? So example, in USB, when you have a keyboard, mouse and all, you have a HID profile, right? Human interface devices. So similarly, when you have a pen drive, hard drive, you have mass storage classes. So similar to that, so you have, so there were these are very basic, but like in industry we have a, smart home profile, home automation profile, and then like we have a street light profile. So there are multiple profiles. So maybe like we can go through one of the uh, um, one of live example from some vendors, basically. So coming to the wearable devices, Nordic was one of the very fast growing chipset vendor, basically. Um, here I just wanted to show a couple of examples which are already available. TI, BLE, stack user guide. So these all maybe like Gopal sir in the afternoon, you can he can run through little bit on these code level things which he will be demonstrating on one of our kit based on CC26, and we have one hardware based on NRF, basically NRF 5240. Right, so Bluetooth application, the stack. I was just trying to see the profiles. Okay, so it's getting little bit more really fine. Yeah, you can see here. Really, device information, service, sorry. Okay. Flash. Okay, sorry. Let me not fiddle with these things. Um, let me quickly go over here. So coming to the vendors, chip vendors, basically, so quickly I can list you a couple of things. The first one I would say Qualcomm, which earlier supposed to be CSR. So this is one of the world leading chip, you can say. The early Bluetooth mouse and keyboards, and so basically were using these chipsets. One of the chipset you would know, Dialog, which is used in your Apple devices. So now Apple have their own, I believe, dialogue. Then you have now the leading consumer electronics and wearable. You have Nordic. You have Texas Instruments. To be precise, CC 25XX and 25. Yeah, 25 access devices you can look into. Other than this, you have Scilabs, BGM, Blue Gecko. They call Scilab, they call it as a Blue Gecko modules, basically BGM devices. Then you have ST Microelectronics. All other vendors, you have NXP and all, but like I would say these are the kind of leading chipsets. So normally how we do is basically, so you can always go to the Chinese online stores where you can really see how these devices are used in multiple uh, how the what chips and are used in these smartphones and all. So I want to give CC 2650 CC 2640 R2F BLE device beacon. So now, when your students also doing some research and then like they want to find, so the best way I would say from my experience. So normally, first you know what are the major players and major vendors. If you really open your mouse or keyboard, which are quite older and now also, so the CSR chips you will find the dialogue. So these are more from mobile devices, the BLE which is there in your mobile devices. Nordic and Texas Instruments you will find on most of the consumer electronics devices, right? Like say now here you would have seen Beacon is one of these, but like CC26, similarly NRF, if I say NRF 52, based say health watch, or like there are different devices basically. So why I'm saying this is basically, so when you are going for a development and then you want to really select a chipset, you need not to do lot research. So easy way is basically you can see which chipset is going into which device, so probably you can select. So this is a small list I wanted to give in terms of Bluetooth chips and vendors. Then one of the interesting topic I wanted to cover is basically, so although we are talking on wearable devices, but most of the wearable devices we try to see they are into healthcare and medical parts. So now if you really see different medical devices, so different medical devices, so each one of they have their own application. Now, how do you categorize what all things goes into this? So a simple example, what I want to give here is, first of all, you have to identify your application. Now, the simplest application could be I want to just monitor my body temperature and they say steps. So you have temperature sensor and you have a accelerometer. Then hardly what you need is one of the small microcontroller connected to these sensors and then transmit this data over a BLE. So that's how your very low computation and with small display you can go with. So normally we call it as a system 1.0, which are based on MCU. Now the second, so this is also wearable. So now what is the what is the major difference? If you really see here, my expectation is not only a simple heart rate or the temperature also, basically. So here it's not only the heart rate or so basically. So we have a user interface. The user is expecting, or you want to check the messages, you want to do some calls basically. So you have whole of the operating system like Android or Linux running on it. basically. So for which you need a microprocessor rather than a microcontroller. So this is your Gen 2 devices, basically, which we call it as a system 2.0. Second generation. So now the third generation, which is more coming to the next level, is basically your integrated with AI/ML. So now when I say AI/ML, integrated with AI/ML, basically, so you can see when you are went for a, say, morning walk, basically, so you really want at spot you want to see what are the calories you have burned and all, basically. So there are two things: either these system 1.0 and system 2.0 sends the data to the cloud. In the cloud, all the analytics has been happened, and then it will display the result. So this is one. But like in our next generation devices, now you might have seen most of the mobiles already have processors which have AI, artificial intelligence and machine learning engines already built in, and those are the processors even which are available for your smart wearable devices, basically. So then there are next generation devices, wearable devices, where your computation happens on the device itself. You need not to transmit the data, do the computation or processing analytics on the cloud. The analytics can be done on the device itself. So which is your system 3.0. It's not only processor, but processor with a lot of additional co-processors. Mainly we call in terms of AI/ML TPU, VPU and GPUs, tensor processing unit, visual processing unit, and graphic processing unit. So you would have heard about NVIDIA, you would have heard about now NVIDIA uses GPU, basically. So the Intel have their own Myrid scale, and then like Google is coming with their TPU part. So this is one of the classification I just wanted to share with you. So when we are building devices, how? So because we come more from these digital space, we more expertise on the processors, operating system, and other things, basically. Now let me quickly take one of the use case of latest microcontroller with BLE. Now, this is the same BLE which Gopal sir would use in the afternoon to demonstrate. Earlier, what happens, you need to have a microcontroller, and then you have a Bluetooth wireless device, not only Bluetooth, any wireless device. So now what happened, most of the wireless controllers comes with integrated microcontroller and RF. If you see here, so there are two things. One is Cortex M3, which is a dedicated microcontroller where you can write your application, and you have one Cortex M0. Sorry for shuffling. This is one of the widely used chip for most of the wearable devices. As I told, the simple way to validate.
போயிடுறாங்க அப்பா எப்படி அதை வந்து இது பண்றது என்ன கொடுத்தாரு ஒரு சின்ன நோட் பேட் கொடுத்தாரு அதை எடுத்துட்டாரு
You can go to a couple of online stores and then you can easily search with these part names basically, so you can easily identify. Now, taking one of the use case of a wireless you can see there is a dedicated microcontroller. This we call it as a application MCU, and then you have a wireless MCU. So there is Cortex M0. This act as your Bluetooth protocol stack. So whatever we discussed in the stack, right? So these things are basically nothing but we will be running those software on ARM Cortex M0, these layers, and then not application layer. So this application layer can be running on Cortex M3. The Bluetooth stack as such will be running on Cortex M0, which have a dedicated RAM and flash. Then this is your actually physical layer, right? You can see DSP modem, digital PLL, ADC, so which is nothing but your link layer and the physical layer. So this section. So now what happened? Your Bluetooth radio combined with one microcontroller to run the stack. This whole of the block basically is my screen visible? Someone can acknowledge? Okay, I think it is visible.
Yes, sir, visible.
Okay, yeah. So now so this on this right side of the block, which you see RF core and then ADC, digital PLL, DSP modem, ARM Cortex M0. So this is your Bluetooth part. Now the beauty is this part with your processor part, both are in single chip basically, along with multiple interfaces. So now all your interfaces are available to connect the sensors. So now these things are now available as a single chip. So for example, we have our the hardware which will be used for your afternoon demonstration is a kind of this device. So now you can see this is the chip what we are talking about, the block diagram, right? And then these are the different sensors. These are the MEMS which are connected to this chip through different digital interfaces. So either it is I2C, SPI, or couple of things would be directly from a GPIO. So these are the digital interfaces which are part of that. Okay. So now after that, like whatever we discussed, the stack and all those things which runs as a software part. Maybe we can look into NRF 52833 block diagram. So this is one more example I can say, similar to CC26. So NRF 52840 is the more widely used, but like it have a design complexity. So we have a new series of processor basic, the microcontroller by Nordic, which is which have your Cortex M4, and then like you can see the similar stuffs, and then you have your Bluetooth, or like here it have multiple. It's not only Bluetooth, you have a multi radio, but you would have a dedicated Bluetooth also, I believe. So this is one of the chip by Nordic. So these are the two examples of what I wanted to show. We have one more. This is based on Nordic. So again, these have multiple sensors on it basically. So you can see some demo in the afternoon. One more thing which I wanted to share a little bit on the development part or product development part is more from a software part. So now we want to develop some device, say Nordic high-tech distance. So now we have for COVID because we have SMT line in Germany, so where we have 200 employees working to produce the hardware. So we are essentially a system on module manufacturer basically. So when we had a challenge to produce our hardware at our factory and the COVID challenge. So for our internal use, we developed this product, which is a kind, we call it as a distancer. The main advantage is basically, so it have a ultra wideband a sensor for the distance calculation basically, so time of flight, what do you say. So using that with NRF 52832 basically, so we built this distancer product, okay, so which can be used for social distancing. So each of the employee can wear, and then whenever they come within a particular range, so the default range is say 2 meters. So if it is within that, it will be for, like here you can see it shows a red LED indication basically. Now coming to the software, that's what I wanted to say. So now today what using for microcontrollers. So that is one of the interesting topic you have to see, because what we have discussed is that at stack level. Now this stack either it can be running as a non-OS part, but if you have some applications where you want to develop multiple threads, multiple sensors you want to read, and you want to use some IoT latest protocols which you cannot develop from scratch, so mostly you will fall back on some RTOS. So one of the very famous RTOS is your free RTOS. Okay, so now in this similar to free RTOS, Zephyr is the latest RTOS basically, which is used now highly for IoT. Highly for IoT basically, and supported by Gens. Giant companies like Google, Facebook, so you have big companies behind this project, and the beauty is basically it minute. Oh, no, sorry. So this would be your upcoming. So currently you can say in top 5, top 1 is your free RTOS, but this is the RTOS which will be your next generation IoT RTOS basically. So you can, if you see on the members part, basically all big companies are the members of these open source projects. So it is a Linux Foundation project. So Zephyr is a new RTOS. Zephyr is a new RTOS, and the beauty is it is derived from a Linux operating system. So what happens? Whatever the security or the latest development in terms of middleware and all those things are easy available, ready available in this RTOS. So even the Bluetooth stack which we have used to develop this product, basically Nordic, our distancer product, basically we have used Zephyr RTOS, and then we are developing multiple IoT products for our customers with this same RTOS. So what I will do is I will stop myself here. Before stopping, let me quickly recap. What we have seen is basically we have first spent a little bit of time more talking about different wireless communications. We saw that, like, for the sensors, it's you what the wireless technologies you can look into is your different Zigbee, Z-Wave, Thread, LoRa kind of technologies. Basically in IoT you have NB-IoT. So these are the terms you might have heard about. So now then next our focus were how we can use Bluetooth, especially for wearable devices. So for that, like we have seen and also we saw while discussing this what which wireless have what kind of capabilities and why need to be used. So then we saw the versions of the Bluetooth, and mainly you have to when you are selecting the Bluetooth you have to see the data rates, right? So initially Bluetooth Classic was more oriented towards the mid data range, mainly for audio and pictures, file transfers and all with portable devices. But then Bluetooth Low Energy started with the IoT motivation, right? So some differences. Then we saw a little bit on the block layer, frequency and the things, and then mainly how the software implementation for programming, what is the software implementation needed, list of couple of vendors, Bluetooth chip vendors. Then we saw the taken a small example of block diagram of 2 chips. So what I will do, I will little bit fine tune my PPT and then share it maybe end of the day or so. Excuse me for that. And then we have also seen a NRF52 series MCU architecture, 2 chips architectures we have seen, where you need not to have a microcontroller and a Bluetooth module. You can have both in same chip. You just have to connect the sensors to these chips using different interfaces. And then we saw one of the we little bit discussed what kind of product we have developed in terms. And finally, I concluded with not only at a Bluetooth, below Bluetooth, you need some RTOS. So it's good if you can explore some very standard RTOS like Zephyr, which is today when you say Android is running on Linux. So similar to that, tomorrow when you are seeing multiple products, you would see Zephyr in those products basically. So here I want to just conclude and say that, like, for next 15 minutes we can discuss. I can see what are the chat requests we have got. Okay, nothing much. So you can post your queries, if any, basically, so that we can we can discuss. We can discuss. I can answer a couple of queries basically.
Dear participants, any queries you can ask, or else you can post your queries in the chat box. Sir, I think no queries.
No problem, sir. So afternoon, whatever we discuss little bit here and there, maybe like I have spreaded information. So what I will do, I will keep those information in my PPT. I will update the presentation and share with you.
Yes,
And,
sir.
my contact information is there available.
Okay,
So
sir.
there are a couple of other things. So one of, as I told, like this is an open source hardware which we have built in India against Raspberry Pi, basically. So you can have a look on this as a gateway, right? Like where we are building a big community of 1 lakh IoT engineers. And then as a FiTech, what we do kind of stuff, these things are available. Probably what I will do is I will put a few more information, whatever we discussed, but it was scattered, and then share this presentation to you guys.
Yes, sir. Fine.
Thank
I will
you.
share that to the participants.
Yeah.
Thank you, sir. It was very wonderful session. And then the continuation to this session, we'll have answer in the next session. Thank you, sir. Thank you very much for accepting our invitation for the presentation.
Yeah. Thank you. Bye-bye.
Thank you. Thank you, sir. We'll end the meeting now. And then the next session will start at 2 o'clock. Please log in at 1:50.